As a very talented and experienced software developer, there are two things I excel at: spending more time than necessary reinventing the wheel and, in the end, inventing a wheel that barely works as planned. In all seriousness, in software development, creating simple and efficient solutions is one of the most difficult tasks. The trick is to employ known design patterns, existing tools, and potential lessons learned into the process. This is especially true these days, when development speed and time to market are of the essence, so wasting resources and effort on problems already solved is not acceptable anymore. In recent years, we are seeing a lot of advancements in the tech world aimed to help you do just that. Focus on developing a solution for the actual problem, and use smart, efficient tools for anything else. Deployment-wise, in the span of 10 years, we moved from self-hosted dedicated servers to pushing things to the edge with just a couple of clicks. On the front end, tools such as Figma or Adobe XD output most of the UI for you, and everything else can be done with a lightweight UI library that feels closer than ever to plain JavaScript. In this video, we'll focus on the backend. I posted a video in the past presenting the benefits of backend as a service solutions such as Firebase or Supabase. Today, I want to take a closer look at Pocketbase, an open-source backend solution focused on simplicity and portability. To give things a bit of context, while analyzing Pocketbase's features, I am also going to show you the alternative of building the same things from scratch with Spring and Java. These are two of the most established tools for backend development. Before moving forward, I want to outline that Pocketbase and Backend as a Service products are not a one-size-fits-all solution. Of course, depending on the complexity of your app, the number of concurrent users and other specific requirements, you will find a lot of use cases when a proper in-house backend solution needs to be built from scratch. Okay, to get things started, simply download the Pocketbase app. Once you've downloaded and extracted the archive, you could start the application by running the following console command in the extracted directory. A Golang-based web server is started, and now we can access the Pocketbase admin dashboard UI at the following URL. When you first access the dashboard, you'll need to create an admin account using an email and a password. Now, for the interesting part, Pocketbase uses SQLite under the hood and allows you to easily create collections, or in other words, SQLite tables we can use to store our data in. Let's go ahead and click on the New Collection button and the side panel will slide in. There are two types of supported collections. Base collection, which is the default type and it could be used to store any application data. This comes with a few default system fields. An ID, which will be used as a primary key, and two audit columns to autosave the created and the last updated dates. Authentication collections are also supported. They inherit anything from the base collection, but with some additional special fields to help you manage your app users, providing various authentication options. The following system fields are provided here by default: a username, an email visibility, and a verified Boolean flag. I am mentioning all this to outline that, even if Pocketbase is small, it still provides sensible defaults and enforces some well-known patterns. Back to the dashboard, let's create a one-to-many collection structure, which will allow us to maintain a list of movies with our review or rating. First, let's create a movie list collection with a name and the owner ID pointing to the authenticated user. We can enforce some field level validation, so our name will have a maximum of 100 characters, and let's avoid having null or empty values. Next, we'll create a second collection called movies with a name, a score, and, for the fun of it, to outline the type of fields supported by our backend, let's add a column to store the IMDb URL for our movie. Finally, in pretty much any project, your data will be related, and in our case, we can link the movie collection to the list via relation type field. There are some options in here as well, and we can choose, for instance, to propagate the delete action of the parent to all children of the relationship. If you are not familiar with the concept, a one-to-many relationship assumes a parent and a list of children. In our case, the movie list is the parent, and it can have multiple movies associated with it. So, in other words, a list can contain multiple movies, but a movie can only be part of a single list. Okay, so we have the database structure in place, and there is one additional thing we need to do before moving forward: handling security. Let's click on the API Rules tab, and you'll see in here 5 specific actions, all set to admin only. These actions cover the create, read, update, and delete basic operations, and they offer us an easy and convenient way to handle security and access at the collection level. Each rule could be set to null, meaning only admins are authorized to perform the action, empty string, which covers admins, authenticated, and guest users, and non-empty strings, specifying a rule that the users have to satisfy in order to perform the actions. Pocketbase gives you details about the available fields and offers autocomplete support for your rules definition. For instance, we can make sure that only the appropriate user can update its own list with the following rule. Before comparing this experience with the Java workflow, let's take a quick look at how we can work with these collections. To consume this data, Pocketbase offers a JavaScript SDK we can add into any server or web project. Let's install it using the following command, and then in a JavaScript file, we'll establish a connection to our backend. Then we can simply make a getList call to the collection to fetch all the information, or we can send a create request to add a new record in our collection. Coming from a backend background, this is pretty mind-blowing for me. Let's now spend a minute looking at what we need to do to have this working in a Java context. We'll need the following: Spring Boot to have access to the Spring ecosystem and easily create REST APIs, Hibernate as an ORM to easily map database tables to actual Java objects, and the Swagger generator to auto-create the JavaScript code needed to query the REST API. I'll skip over the installation steps, since the project setup alone would take way longer than the entire Pocketbase setup we did earlier. Now, for the tables, we'll create two plain old Java objects, or in short POJOs, and we'll annotate them with some specific Hibernate tags. Based on these annotations, the ORM can create the database tables for us. However, keep in mind that this is frowned upon, and you should actually use a database migration tool such as Liquibase to handle any table structural changes. Next, we'll use Spring Data, which has a lot of useful utilities, to abstract away some of the database work, and we'll get access to some default create, read, update, and delete methods. Then, let's create a REST controller, where we'll expose the previous operations to the public via REST endpoints. Finally, we'll need to add a security layer on top of this using Spring Security, which is quite tedious at times and requires some knowledge on the matter. In all fairness, we can skip some of these steps by using the hypermedia as the engine of application state approach Spring offers, but the whole process is still pretty overwhelming. As I mentioned earlier, full-fledged backend implementations are not going anywhere and will still be the preferred approach for complex software and enterprise solutions. However, for smaller apps and prototypes, solutions such as Pocketbase, which are actually pretty reliable and scalable, are a no-brainer. As a quick FYI, if you are interested in more details about building REST APIs in the Java world, check out the video linked into the top right corner. Okay, getting back to Pocketbase, its collection support is not the only selling point. Pretty much any backend as a service offers file uploading and storage support. In the dashboard, we can add a poster field to our movie collection, but this time the field type will be marked as file. Then, using the JavaScript SDK, we can simply send files over to the server in a seamless manner. By default, Pocketbase uses the local file system to store uploaded files. However, these days it is much more common to store data in an S3 compatible storage. We can simply enable this by going to Settings, Storage, and toggle the S3 storage option. While we are in the Settings tab, let's explore some other options. Pocketbase comes built in with default email templates, which are sent throughout the authentication process and which can be easily updated as well. Setting an external SMTP server is also very straightforward. I mentioned authentication, and Pocketbase supports multiple authentication providers as well, all easily configurable with just a couple of clicks. I am not going to compare setting up different authentication systems or an SMTP server in Java, but believe me, it's not going to be this easy. Keep in mind that Pocketbase is still in its early stages of development. However, there is a lot of interest around it, and things could only get better moving forward. While small, Pocketbase offers other features I didn't get a chance to mention in this video, such as access to logs or real-time support, so if you have a few minutes to spare, head over to their website to check out more. Let me know if you see any feature for Pocketbase in your projects, and if you found this video useful, please consider liking it. Until next time, thank you for watching.